Hello everyone. In this video, let's study chapter 7. Okay, and before that, I have an announcement for the quiz 3. It's open already, so it will be closed on February 25. Okay, February 25 is, I think, Tuesday night. Okay, so you have to complete quiz 3. Okay, let's get into chapter 7, basic types. Okay, basic types. Basic means in C program that is built-in types, like integer, okay, integer, long integer, short integer, unsigned integer, okay, floating type, float double and long double, character, bool, actually bool type, it included in C99 version. Previous version there is no boolean. Okay, C support two fundamentally different kinds of numeric types, integer and floating. Okay, the value of integer data type are whole numbers. It's like 0, 1, 2, 3, 4, minus 1, 2, 3, 4, okay, something like that. It's a whole number, right? The value of a floating type can have a fraction part, decimal part, and fraction part, right? That is a floating data type. The integer type, like signed, unsigned. Signed means plus, negative, right? Positive, negative value, but unsigned is no using the positive, negative. Okay, let's see detail of signed and unsigned. Left most bit of signed integer is a signed bit is 0 if the number is positive or 0. So 1 if it is negative. Leftmost bit, right? Very left side. That used for sign bit. Okay. The largest 16-bit integer has a binary representation. Like okay, how many? 16, right? So the leftmost bit is only 0, but the others is 1, all 1, right? Which has value 32,767. That means 2 to the power of 15 minus 1. Okay. The largest 32-bit, the leftmost bit only 0, but the others is all 1, right? The value is 2,147 million, right? 2,147 million 483,647. That means 2 to the power of 31 minus 1, right? So big, right? An integer with no sign bit. The leftmost bit is considered part of number's magnitude. It says to be unsigned. Okay. So unsigned. So unsigned, the integer with no sign bit. Okay, so for the 16-bit unsigned number is gonna be 65,535. That means 2 to the power 16 minus 1, right? So, okay, because of there is no sign bit, so the leftmost we can use, okay? So it's gonna be 1, okay? And this part, okay, 16-bit and 32-bit is gonna be 1. Okay, there is no sign bit for unsigned number, so it's gonna be 32-bit unsigned integer is like 4,294,967,295. It is 2 to the power of 32 minus 1. Okay, so big, right? So big number. Okay, let's say signed bit and signed integer and unsigned integer. By default, integer value variable sign unsigned, right? Signed. Okay. In C, the leftmost bit reserved for sign, right? Let's go back to previous. So this is the reserve for the sign bit. Okay. That means the leftmost bit reserved for the sign, right? To tell the compiler the variable has no sign bit, declare it to be unsigned, right? We have to declare that is unsigned. Unsigned number are primarily used for system program and low-level machine-dependent application. Okay, integer type. Int type is usually 32-bit, but maybe 16-bit on older CPU. Currently, I know 32 and 64-bit. I believe no more 16-bit CPU. Currently is 32 or 64. Okay. Long integers may have more bits than ordinary integers. Short integers may have fewer bits. Okay, so long and short, as well as signed, unsigned, can be combined with int to form integer type. Only 6 combinations produce different types: short int, long int, unsigned short int, unsigned int, unsigned long int. Okay. The order of the specifier doesn't matter. Also, the word int can be dropped. Long int can be abbreviated to just long. Okay. Okay. The range of value represented by each of the 6 integer type varies from one machine to another. However, the C standard requires that short int, long int must each cover a certain minimum range of value. Okay. Also, int must not be shorter than short. Int, long int must be. Okay, there is so many integer data type, right? So long int, short int. Okay. So let's see. Typical range of value for integer types on 16-bit machine looks like that. Short int. So unsigned long int is largest value, right? It has largest value, right? But this, the range of the size is long int is almost same because of that is minus, right? Negative. The range are almost the same, but This is the bigger, right? And unsigned int, unsigned short. So there is 6 data type for integer, but normally I use, in my case, I use int. If you have a special case, you can use unsigned. Okay, unsigned. Otherwise, normally int is popular use for program normally. Otherwise, we have to define which integer type use. Okay. This is a 32-bit. You may check. It's a little bit. It's almost same, I think, but this part int is so much increase than 16-bit, 32-bit. Okay, check that, and then I believe 32-bit most, and 64-bit is much bigger, right? This, okay. This is 16, 32, 46, 64. Okay. Header, like a limits that header file defines macros that represent the smallest and largest value of each integer data type. Okay. In C99 is a C version, so C99 provide 2 additional standard integer type, like long int, unsigned long int. Okay. It's kind of both long type are required to be at least 64-bit wide. The range of long int value is typically minus 2 to the power of 63 to 2 to the power of 63 minus 1. Wow, so big, right? I believe there is, no chance to use long int, but special case we can use. But that is so big number, right? If you see the unsigned is much bigger, like a double of the positive side. You get 2 times 9 is 18, right? Oh, so big, right? Okay, let's go. Okay, and short int, long int, and long int. When unsigned, that is kinds of extended integer type, both signed and unsigned. Okay, so many kinds of data type in integer, right? Let's see, integer constants, numbers that appear in the text of a program. C allows what integer constant to be written in decimal base 10, octal base 8, hexadecimal base 16. I believe you learned that, right? Octal base 8 and hexadecimal base 16 and base 2 binary. Okay. I believe if you took computer architecture, you may be familiar with that, the terms and the octal and hexadecimal, something like that. Okay. All right. Octal and hexadecimal number. I believe you know how to convert from decimal to octal, and from octal to decimal, converting, right? I don't want to explain how to convert here, but you may understand. Okay. And this is octal and this is hexadecimal. Okay. You just refresh if you forgot. Alright, integer constant, decimal constant contain digit between 0 and 9, but must not begin with 0. Okay, not begin, because to distinguish there is a decimal or octal or hexadecimal or some binary number. So we never use 0 in decimal number, right? Just use 15, 299, okay, 32,767, something like that. Okay, octal constant contain only digit between 0 and 7, right? Octal number base 8, right? So must begin with 0 because of octal, right? 0, 1, 7, 0, 3, 7, 7, something like that. Okay? Hexadecimal also. But hexadecimal use digit between 0 and 9 and A, B, C, D, and F. Okay? So always begin with 0x to verify that is hexadecimal. So 0x F. That means that is 15, right? And you can convert it. Either way, either upper or lower case, doesn't matter. Okay? Integer constant, decimal integer constant is normally int, right? Int. Okay, so let's go next. Okay, long integer. Compiler to force the compiler to treat constant as a long integer, just to follow with the letter L or small low letter L. So it's like a 15L. So like a 0377L. That is a octal, right? Octal value with L. That means constant as a long integer. Okay, so L, kinds of L. Okay, U in this case unsigned we can use, and the value U something like that. Okay, so in C actually very specified the number. In integer we are still stay in integer data type, right? So L and U we can use like that. 0x FFF UL, right? The order of L, U, UL doesn't matter. Okay? Okay? Okay. It's integer constants in C, LL or LL, right? Long integer. Okay, UU, LL, something like that. Okay. So hexadecimal or octal constant is possible int, unsigned int, long int, unsigned long int, long int, something like that. Okay, it's the same, right? Okay, and overflow. Okay, integer overflow. So sometimes we have overflow when we have arithmetic operation performed on integer, it's possible that result will be too large to represent. So for example, when arithmetic operation is performed on two integer value, the result must be able to represent it as an int, right? In case too many bits require, we say overflow has occurred. Okay. The behavior when integer overflow occurs depends on whether the operands were assigned or unsigned. Okay. When overflow occurs during operation on signed integer, in this case the program's behavior is undefined, but unsigned unsigned case, the result is defined. We got the correct answer modular 2 to the power of n. So this n is number of bits used to store the result. Okay, so let's see reading and writing integer. Okay, in C. Okay, reading, writing on data type. When reading and writing unsigned integer, use the letter U, O, or X instead of D. D, when you use D, you know, there is a decimal integer, right? But unsigned integer, U, right? You can use like that. Okay. You just scanf, right? Scanf is reading, yeah, and printf writing, right? So I believe you know scanf and printf, right? Okay. We have to put the letter H in front of D, O, U, X, H, right? D, right? In front of D, we add H, something like that. Short in case of writing short integer. Okay, let's see. Next. In this case, sum.c program sums a series of integer. There is a problem, a single problem with this program that the sum or one of the input numbers might exceed the largest value allowed for an int variable. Here is what might happen if the program is run on the machine whose integers are 16-bit long. Okay. For example, this program sums a series of integer, enter integer 0 to terminate, something like that. The sum is minus something. When overflow occurs, the signed number, the overcome is undefined. The program can be improved by using long variable. Okay, because of the calculated value, calculation after the result is gonna be bigger than integer range. If that is signed, there is no defined for the overflowing. So we have to change the data type. Okay, let me open the Visual Studio Code to test. Okay, Let me check. Hold on a second. Okay. Sum 2. Okay. I believe I have chapter 7. Let me see. Over. Chapter 7. If I don't have sum 2, I have to. Okay, I don't have. Okay. Okay, anyway. I don't have sum 2. I try to find, but there is no previous one. Okay, anyway. I just type code. Okay, I like to coding. Okay, let's start. Okay, processor, right? We have to include std standard input output header file, right? To use what? Why we have to include to my program here? To use the function, right? Standard input output, standard print, standard input reading, okay? Scanf and printf, something like that, included in the stdio.header file, okay? Define main void, okay, with void parameter, return data type in the main is just return, so we have return 0, okay. Long data type and sum is gonna be 0, we declare, and print f from parentheses, and this program sums a series of integers, okay, integers dot and backslash and semicolon, and printf again and enter integers 0 to terminate close, okay, and semicolon, and read scanf the percent ld, right, ld used, ld, and what's the ampersand and semicolon, okay. So while what n is not equal to 0 during that time, not equal to, that means n should be 1, 2 or something except 0. If 0, I'm sorry, if n is not equal to 0, that is true, right? So if n is 1 is not equal to 0, that is true, right? If n is 0, it terminates the while loop, right? So sum plus and scanf again percent LD and percent and semicolon and printf. The sum is what? Percent LD backslash n comma sum. Okay, and return 0. Looks great, and then let's save it. Okay, let's save it. Spring. Where is it? Okay. Over here, sum2. Okay, sum2.c. Okay. Right, and saved it, and then run code. Okay. Okay, over here, enter integers 0 to terminate. So if I type like 100, I entered. It takes a long time. Oh, one more? Okay. Okay, I gotcha. Because we are in while loop. Okay, 10 and 30, 100, 500. If I type 0, it terminates. Okay? So the sum is 640, right? Okay, because the sum of them, all of them, is 640, right? It's correct. Okay, it's good. So, but, okay, that's good. Okay, that is a sum 2. Okay, and floating data type right now. Okay. Let me stop here, and then I'll be back soon. Okay, thank you.